It appeared without announcement, without sound, and without regard for the order that governs our days. Somewhere in the infinite stretches of space, where stars scatter like flecks of sand across an endless ocean, something moved in defiance of patterns that had remained unchanged for eons. Scientists assigned it a name, 3I divided by Atlas, but even that label failed to capture the alien nature of what had arrived. This was no ordinary object. It was a wanderer from the depths beyond our solar system, sliding silently through the familiar orbits like a shadow cutting across a cathedral floor. There was no glowing tail, no gravitational nudge to slow it down, no hint of allegiance to the planets it passed. It existed entirely on its own terms. The first observation barely registered. A faint spark, almost lost in the tapestry of stars, went unnoticed at first glance, but within hours, calculations revealed a truth that defied expectation. This object wasn't bound to the sun. It followed a hyperbolic path, an unmistakable signature of something alien, something passing through only once, destined never to return. For those who spend their lives tracing the heavens, it was a mix of awe and disquiet. Discovering such a phenomenon was almost inevitable with modern astronomy, but seeing it glide across the void, silent and indifferent, was profoundly unsettling. Interstellar space stretches like an endless desert, where distant suns flicker like faraway campfires. Tiny fragments of rock and ice drift through this emptiness, remnants of violent collisions, fragments cast adrift for millions of years. In that sense, an object crossing our path is unsurprising. Yet 3I divided by Atlas was different. Its speed defied familiar expectations. Its reflective surface hinted at textures that instruments could not decipher. Unlike typical comets, it carried no gaseous halo, no comforting markers to reassure scientists. It was clothed entirely in quiet, a silent enigma moving at impossible velocities. And it was not humanity's first brush with the unknown. Just a few years earlier, Oumuamua had startled astronomers, its elongated, cigar-like shape and unexplained acceleration defying conventional understanding. Many had hoped the next visitor would clarify these mysteries. Instead, 3I divided by Atlas arrived, offering more questions than answers, deepening the uncertainty, revealing contradictions the cosmos was unwilling to explain. In science, fear is subtle. It does not scream or terrorize. It whispers in anomalies, in instruments that behave unexpectedly, in calculations that resist closure. As astronomers traced the object's trajectory backward, the silence of its origin was overwhelming. Where had it come from? Was it merely a shard of cosmic debris, or a fragment of something far larger and stranger than imagination allowed? The questions were not born from threat. The path of 3I divided by Atlas would never intersect with Earth. The concern was existential, the realization that our understanding of physics might be far more fragile than we believed, that the universe might be stranger than we dared imagine. For centuries, humanity has confronted the unknown with story. Ancient civilizations transformed fear into gods and spirits. The age of reason turned it into equations and hypotheses. Yet the core sensation remained unchanged. Curiosity braided with unease. Watching 3I, divided by Atlas, traverse the sky, was to experience that duality firsthand. It reminded observers that the solar system is not a closed fortress but a crossroad, where wanderers from distant corners may appear without warning. This is not merely a tale of a rock drifting in space. It is a story of humanity confronting what it cannot yet explain. What is 3I divided by Atlas? Why does it move the way it does? What secrets has it carried across the void? The danger is not in the object itself, but in the silence surrounding it. Silence in science is never emptiness. It is a puzzle, a challenge to human understanding, and in that silence lies the fragility of certainty, the reminder that even centuries of observation cannot fully tame the cosmos. The discovery of 3I divided by Atlas did not erupt in spectacle. It began quietly, in the spring of 2020, when the Atlas Survey, a network of telescopes in Hawaii, designed to track near-Earth objects, was scanning the heavens. Its mission was defensive, aimed at detecting potential threats to Earth. Night after night, its instruments recorded streams of light, documenting countless small bodies orbiting the sun. Most nights offered predictable results, familiar asteroids, occasional faint comets awakening under sunlight. But on this night, something anomalous appeared. Its movement did not align with planetary gravity. Its path bent around the sun, not in a loop, but in a hyperbola, a trajectory that left no doubt about its interstellar origin. This marked the third known visitor of its kind. Oumuamua appeared in 2017, 2I divided by Boris in 2019, and now 3I divided by Atlas, arriving silently to challenge assumptions. Unlike its predecessors, which exhibited recognizable comet-like behavior, this newcomer seemed muted, almost deliberately subtle, resisting the patterns astronomers expected. Instruments hummed with recalculations. Observers leaned closer, debating, adjusting, and questioning. Moments like this carry a historical resonance. Discovery often arrives quietly, only to later become legendary. Galileo glimpsed moons of Jupiter through a crude telescope. Herschel noticed a faint star that revealed Uranus. Hubble revealed galaxies beyond the Milky Way. Yet, in the instant of realization there is nothing glamorous, just patient observation, the faint thrill of detecting something extraordinary, and the creeping awareness that the universe holds more than humanity can grasp. 3I divided by Atlas glided through space like a messenger from the unknown, indifferent to our curiosity, immune to explanation. It carried no cometary signature, no familiar trail of dust or gas. It moved at a velocity that defied easy understanding. Its surface reflected light in ways that instruments could not fully decode, and its silence spoke volumes, reminding us that the cosmos is vast, indifferent, and full of mysteries that challenge every assumption. For those who watch the skies, the moment was humbling. Here was evidence that our solar system is not an isolated fortress, but part of a much larger, untamed universe. Wanderers will come, glide past, and vanish. And when they do, they leave behind questions that echo louder than answers. 3I divided by Atlas is not a threat in the conventional sense. It is a challenge to imagination, a silent reminder of how much remains beyond comprehension, and a signal that humanity's knowledge, though immense, is still fragile in the face of cosmic scale. Modern astronomy tells its tales differently than the old myths of gods and monsters. Now stories are conveyed through streams of digital images, nights spent cross-checking tiny fluctuations of light, and the constant hum of computers decoding the cosmos. Yet even within this precise machinery, the universe still whispers enigmas waiting to be discovered. When the astronomers first realized what they had captured with their instruments, a quiet shock rippled across the scientific world. The solar system, so long regarded as a neat, self-contained arena, had been penetrated once more by a visitor from far beyond. The scientists were not seeking interstellar wanderers. Their focus was on defense, vigilance against dangers that might strike without warning. The Atlas Survey, a network of telescopes perched in Hawaii, was created to spot potential Earth-threatening objects. Asteroids, comets, or debris on collision courses were the original targets. Every night, its instruments recorded countless small bodies orbiting the sun, the routine almost monotonous. Occasionally, a comet would drift into view, glowing faintly as sunlight released its hidden gases. Often, minor asteroids would pass silently, their presence noted but unremarkable. Yet among this predictable traffic, something appeared that did not fit any established pattern. A fragment, ancient and solitary, drifting across millions of kilometers of emptiness, had entered the scope of human observation. Its existence was subtle but undeniable, almost unnoticeable until the calculations began. While the names of the observers might fade into the footnotes of history, the significance of their work resonated. They were not merely technicians. They were custodians of humanity's gaze, the lineage of those who stare into the dark without knowing what may appear. Their reward is seldom recognition. More often, it is the profound discomfort of realizing that the universe is stranger than it seems. 3I divided by Atlas did not offer easy answers. It brought questions, ones that refused to settle neatly. Where had it originated? How long had it journeyed across the void? What traces of ancient collisions were etched onto its surface, hidden from view? Excitement and unease intertwined as astronomers recalculated its course, refining trajectories, confirming the undeniable truth. It was unbound, indifferent to planets, untethered from the sun's influence. It did not behave like a comet, leaving no visible tail or hint of ice and vapor, nor did it resemble a typical asteroid. Its surface shimmered with reflective qualities that defied classification. Its silence, its refusal to conform, elevated it beyond a mere discovery. It became a story, a riddle the cosmos had set in motion. When news of the discovery began to circulate beyond the small circle of survey teams and orbital calculators, the scientific community paused. Interstellar visitors were no longer unprecedented. Oumuamua had arrived in 2017, followed by Borisov in 2019, But each time the arrival of such objects challenged assumptions, nudged astronomers toward uncomfortable possibilities, and reminded humanity that the universe is not static. The memory of Oumuamua remained vivid. When it was first observed, it had been assumed to be a comet, a chunk of frozen matter that would flare as sunlight evaporated its surface. Instead, it defied expectations. It lacked a tail, a dust cloud, or any visible outgassing. Its tumbling motion indicated an unusually elongated shape, the angles debated endlessly, cigar-like to some, pancake-thin to others. Most strikingly, its speed did not fully align with gravitational predictions, suggesting a subtle acceleration beyond conventional forces. Some even speculated, in whispers that lingered long after the object departed, whether it might be artificial, a probe or a starbound sail. This history cast a long shadow over the observation of 3I divided by Atlas. The scientific community approached with a mixture of hope and caution. Could this new visitor confirm Oumuamua's anomalies, or would it reveal a pattern of ordinary interstellar debris? Would it resolve questions that had haunted astronomers for years, or deepen the sense of cosmic uncertainty? At first glance, Atlas appeared quieter, less volatile. Its light curve was smoother, its path predictable, seemingly less dramatic than its predecessors. Yet, closer inspection revealed subtleties that were both intriguing and disconcerting. Its reflection was irregular, suggesting complexity beneath the surface. No comet-like plume appeared, no expected shedding of ice. In its apparent normalcy, there was an odd, unsettling defiance. It resembled its predecessors in outline, yet each detail diverged from expectation. The cosmos seemed to present a familiar shape, while hiding its true nature, and the repetition of this phenomenon amplified unease. With Oumuamua, an anomaly might be dismissed as a rare coincidence. With Borisov, the threshold for speculation increased. Now, with 3I divided by Atlas, the pattern began to demand attention. Interstellar space might not be a realm of uniform, predictable behavior, but a stage where fragments of ancient worlds drift with characteristics humans cannot categorize. Astronomers speak cautiously about paradigm shifts. 1 anomaly can be rationalized. 2 can prompt re-evaluation. 3, however, signals a systemic challenge. The old expectation that objects from other stars would resemble those formed within our system was becoming untenable. Perhaps these interstellar travelers were not exceptions but representatives of a broader variety, shaped by processes and collisions far beyond human observation. Perhaps they were not mere accidents of chance but emissaries of distant, unknown physics, bearing the signatures of realms unreachable by telescopes. In this light, each new visitor carries the weight of all that came before. They are more than their trajectories or dimensions. They are mirrors reflecting the limits of knowledge, reminders of how fragile certainty remains. 3I divided by Atlas bore this burden fully. To some, it was an opportunity to catalogue new variations in cosmic debris. To others, it was a profound signal. The solar system is permeable, the universe restless, and what appears familiar is only an illusion crafted by perspective. Journalists framed it dramatically, hinting at alien probes or hidden technology. Scientists remained measured, but even their restraint contained an undertone of apprehension. There is something more unsettling about recurrence than about the unknown itself. Oumuamua had left unresolved questions. Now Atlas returned those questions, sharper and more insistent. Humanity was reminded that the void beyond the planets is not a place of predictable rules, but a wilderness of possibilities. Each calculation, each observation, deepened the paradox. Speed, reflectivity, path, all suggested that 3I divided by Atlas was both familiar and alien. It refused to settle neatly into categories crafted by centuries of astronomy. Yet, in its defiance, there was beauty. It illustrated the subtle power of the cosmos, the way the universe teases understanding while revealing glimpses of structure too immense and intricate for immediate comprehension. The significance extends beyond a single object. It speaks to a broader narrative, one of preparation, discovery, and humility. Scientists scanning the heavens are guardians, not heroes, watching for threats yet finding marvels. Their work reminds humanity that observation is never passive. Every glimpse of light, every faint signal, may carry echoes of events that transpired millions of years ago in regions of space that humans will never reach. Each interstellar visitor is a messenger, silent yet profound, a challenge to perception and an invitation to wonder. 3I divided by Atlas is more than rock and ice. It is a testament to the restless journey of matter across incomprehensible distances. It is a puzzle that refuses resolution, a quiet herald of the universe's vastness and complexity, and above all, it is a reminder that for all human knowledge, the cosmos can still surprise, unsettle, and inspire, delivering mysteries that cannot be ignored, no matter how sophisticated the instruments, no matter how prepared the observer. When astronomers traced its path with painstaking accuracy, the reality became impossible to ignore. 3I divided by Atlas was not a child of the Sun. Its orbit wasn't a closed ellipse like the planets, nor a predictable elongated loop like a comet. It followed a hyperbolic trajectory, a course that spoke of exile, of passage, and of an origin outside the solar system. Unlike the familiar dances of the night sky, it had no plan to return. Once it brushed past the Sun, it would continue outward, vanishing into interstellar darkness, leaving the planets and comets entirely untouched. This revelation brought a strange mix of thrill and anxiety. Exhilaration because it confirmed something profound. The solar system is not a sealed fortress but a junction, a crossroad through which objects from distant stars may pass unnoticed. Anxiety because the unbound orbit was a stark reminder of humanity's limited influence. The Sun, master of its planetary family, could only tug gently at this outsider. Even our closest star is powerless against a true interstellar traveler. Researchers tried to trace its origin, extending its trajectory backward across unimaginable distances, but every calculation quickly dissolved into uncertainty. Tiny errors amplified over light years, and the origin remained hidden in obscurity. Was it flung from a young planetary system after a violent collision? A fragment of a shattered moon expelled during the chaotic birth of alien worlds? Each possibility was speculation. Its birthplace, like its destination, remained a secret of the cosmos. Its velocity added to the unease. This was no ordinary wanderer. Comets and asteroids are bound by the Sun's gravity, born and shaped within its domain, their speed confined by predictable limits. 3I divided by Atlas carried momentum from forces experienced millions, perhaps billions of years ago, in regions of space that human eyes will never see. It was a messenger, not only of distance but of time, carrying the imprint of ancient cosmic events. To contemplate its journey is to confront immensity itself. For this fragment to reach the inner solar system, it must have traversed light years of emptiness. In that span, stars were born and died, entire galaxies collided. Civilizations, if they exist, may have risen and fallen, yet it pressed onward, indifferent, until the faint glow of the Sun finally intersected its path. Humanity was fortunate, or perhaps fortunate in its timing, to witness just a fragment of this vast journey. The trajectory itself carried a lesson. The solar system, often imagined as a clockwork of perfect orbits and neat cycles, is vulnerable. Visitors from beyond the stars arrive on paths that ignore boundaries, indifferent to definitions of inside or outside, safe or threatening. 3I divided by Atlas proved that cosmic borders are illusions, fragile and porous, penetrable by forces humans can neither command nor predict. This realization weighed heavily on the astronomers tracking it. Closed systems can be mastered, catalogued, understood. Open systems demand humility. The danger was not a collision. The orbit avoided all planets, but the implications were profound. How many objects drift silently through interstellar space, unseen and unobserved? What might appear next without warning? And if the next visitor were larger, faster, or denser, the consequences could be unimaginable. As it drew closer, every shift in brightness, every subtle curve of its path, became data. Yet that data repeated the same message. This was not a solar system native. Its origin was alien, its motion defiant of local norms. Scientists realized it was a reminder that the universe does not belong to humanity. It never has. Velocity was perhaps the most compelling signal of its foreign nature. Objects formed in the solar system obey predictable ranges of energy, their speed constrained by the Sun's gravity. 3I divided by Atlas traveled faster than anything native to this domain, carrying momentum imparted long ago by some distant cataclysm. Speed in the cosmos is history encoded in motion. It tells of collisions endured, slingshots from massive stars, violent expulsions from young planetary systems. Perhaps it had been torn loose during a planetary collision. Perhaps a giant star's gravity had flung it outward, or it was cast away as a young protoplanetary disk collapsed and reformed. Whatever the cause, that momentum carried it across light years of emptiness until, by chance, it intersected our tiny corner of the galaxy. For the scientists observing it, that speed was both thrilling and disquieting. It confirmed without doubt that this object had come from elsewhere. Yet, it also implied vulnerability. If something as vast and ancient as this could appear suddenly, what else might follow? If fragments of rock or ice can drift unannounced between stars, humanity's sense of security feels illusory. The solar system is not a locked room, and our defenses, planetary or otherwise, are limited to what we can see. The velocity also challenged expectations about physical behavior. At such speeds, exposed ice should sublimate rapidly, producing the telltale tales that make comets recognizable. Yet, 3I divided by Atlas displayed no such familiar glow. It remained silent, hardened, enigmatic, as though the forces that propelled it had stripped it of the usual cosmic signatures. Its surface hinted at stories we cannot yet interpret, a cipher whose code we lack the tools to read. Within the observatories, discussions drifted beyond the purely astronomical. The data raised philosophical questions about space, time, and the scale of human understanding. Relativity provides a framework for motion, explaining how velocities accumulate and time bends for objects approaching the speed of light. Yet here was an object that stretched those concepts into the realm of imagination. Its journey, unbound, unheralded, and untraceable in origin, spoke of a universe that cannot be fully tamed by equations alone. Scientists debated possibilities, weighing each model against the evidence. Its trajectory, speed, and reflective qualities could not be explained entirely by familiar physics. It demanded new perspectives. It was a living reminder that even the most precise calculations are bounded by human understanding. The interstellar traveler forced observers to confront uncertainty at the largest scale, where the smallest miscalculation grows into ambiguity measured in light years. 3I divided by Atlas became more than a rock moving through space. It was a symbol of cosmic freedom, an interstellar exile carrying the weight of ancient events across the galaxy. Its journey was a silent lecture in the vastness of time, a reminder that our planet is just one small waypoint along an immense network of motion and chance. The sun, commanding in its own system, had no power over this interloper. The planets, arranged like clockwork, could only watch as it swept past. And humanity, brief observers in the cosmic theater, was granted a glimpse of a fragment that had traveled farther and faster than any other object in recorded history. Its presence reframed perception. The universe is not a fixed, predictable stage, but a vast, restless arena where unexpected events are inevitable. 3I divided by Atlas thus serves as a warning and a marvel simultaneously. It demonstrates that interstellar space is not uniform or safe, that the familiar patterns of our neighborhood in the galaxy are merely local conventions, and that the universe is always capable of delivering the unforeseen. It is not technology, intelligence, or intention that makes it alien, but the profound fact of its origin, its journey, and its defiance of every expectation rooted in the solar system. Every rotation, every reflective shimmer, every shift along its hyperbolic path reinforces this truth. It is a messenger of scale, history, and mystery, inviting astronomers and humanity alike to recognize the limits of knowledge and the magnitude of what remains unseen. It is a traveler, an exile, and a question written in motion across the cosmos, a question without a definitive answer, yet one that demands contemplation. 3I divided by Atlas compelled a perspective far larger than mere physics. It forced reflection on scale itself. Humanity, confined to a single fragile planet, suddenly felt infinitesimal. Against an object racing across the galaxy with relentless momentum, the Earth seemed tiny, the sun provincial, and human lifetimes like sparks that flare briefly before fading into night. Velocity, in this sense, became unsettling. Not just a measure of kilometers per second, but a mirror of our own stillness amidst a restless universe. The object did not pause, did not slow, did not yield for observation. It surged onward, indifferent to the curiosity it stirred. Its motion carried a silent message. The cosmos does not wait for comprehension. Questions multiplied. Was this rapid journey merely the product of natural events, or did it hint at unknown forces, subtle influences propelling it beyond chance? Oumuamua had displayed unexpected acceleration, and now Atlas surged with its own peculiar vigor. Perhaps velocity itself was the clue, a silent signature of forces beyond human understanding, hinting at mechanisms that govern motion across interstellar distances in ways we have yet to recognize. Telescopes continued to follow its flight, but the mysteries deepened when scientists examined its reflection. Comets usually announce themselves with brilliance, a luminous halo, a streaming tail, as sunlight heats their frozen surfaces. Atlas revealed none of that. Instead, it cast a faint, irregular gleam, a reflection that resisted classification. It neither shimmered with icy brilliance like pristine comets, nor absorbed light like dark asteroids. Its albedo fell in an intermediate gray, suggesting unfamiliar textures or perhaps exotic compounds unknown to the solar system. Further measurements hinted at a patchwork of reflectivity, as though its surface was fractured, scarred, or wrapped in irregular layers. The light it returned seemed almost sentient in its ambiguity, silent yet occasionally catching hints of subtle shine where no dust or gas should exist. It was paradoxical, cold, still, yet luminous in places, a visual riddle challenging observers to decode a message they could not yet read. Spectroscopic analysis deepened the enigma. Instruments strained to extract composition from the faint photons it returned, yet the data refused simple interpretation. There were no markers of water, no molecular signatures aligning with known solar system materials. Its silence was as much scientific as visual, a spectrum speaking in incomplete sentences of a language no one had learned. Perhaps its ice had sublimated eons ago, leaving only a desiccated shell. Perhaps it was rocky, metallic, or coated in compounds forged under alien conditions far from our sun. Some speculated that interstellar radiation over millions of years might have transformed its surface into a dark, almost impervious layer, impervious to heat and light alike. Other, more speculative ideas arose. Could the irregular reflections indicate flat surfaces, perhaps artificially shaped? Angular glints hinted at facets rather than random curves of natural rock. While most scientists dismissed such notions, the questions persisted in quiet conferences, in late-night debates, echoing the uncertainty left by Oumuamua. Another visitor had arrived to provoke curiosity, to confront the imagination with silence where activity might have been expected. The lack of a comet-like tail compounded the challenge. Without visible outgassing, it became nearly impossible to estimate its mass or size with confidence. Astronomers relied on brightness alone, the faint variations of reflected light, and there too lay contradictions. Some readings suggested a compact, dense object, others hinted at a larger, flatter form. Each observation deepened the mystery, expanding uncertainty instead of narrowing it. To study this interstellar traveler was to encounter deliberate ambiguity, as though the universe had drawn a veil over its features, allowing only fragments of truth to pass through. This quiet resistance provoked a new kind of unease. Nature sometimes reveals herself generously, a comet blazing across the sky, a planet moving with perfect rhythm. Atlas, however, belonged to the opposite category. Its surface whispered riddles, its silence hinted at unknown processes, and its elusive signature expanded the gulf between what was known and what might be possible. The object, no larger than a fragment of stone compared to planetary giants, became vast in the imagination, its anomalies multiplying with every passing night. Fear did not stem from collision, it emerged from uncertainty, from the challenge of interpreting meaning from incomplete data. The pursuit of 3I divided by Atlas became as much a test of human ingenuity as of instruments. Studying such a faint, fleeting traveler required the most advanced tools available. NASA's network of telescopes, designed for planetary defense, pivoted to track it. The Atlas survey, which first detected it, continued its meticulous vigilance, providing real-time coordinates to observatories worldwide. Pan-STARRS in Hawaii contributed, refining the trajectory, charting each point of light into a hyperbolic arc that confirmed its interstellar freedom. Other observatories joined, extending the net of observation. The Hubble Space Telescope, though aging, turned its precise optics toward the fragment. Ground-based observatories equipped with adaptive optics captured the faint flickers against a backdrop of distant stars. Each measurement added pieces to the puzzle, yet the puzzle remained unresolved. No matter how many photons were collected, the light curve resisted straightforward interpretation. Some nights suggested rotation, others hinted at a shape defined by alternating light and shadow, as though the object actively defied confinement to a single model. Unlike planets or larger comets, which reveal themselves in images with clarity, Atlas remained a whisper, a tiny point of light among countless stars. Its presence could only be reconstructed mathematically, its existence drawn through careful plotting of brightness and orbital mechanics. It was as if the cosmos itself had hidden the visitor in plain sight, permitting only suggestion to emerge, never certainty. The very act of observation became a meditation on scale, precision, and human limitation. Here was a fragment, small and dim, yet carrying within it a history older than civilizations, older than planets, older than entire star systems. To track it was to peer into the immense patience of the universe, to recognize that even the tiniest object can defy comprehension when time and distance are measured in the billions of years and light years that it had traversed. Every aspect, velocity, reflection, light curve, spectral ambiguity, reminded humanity that this was no ordinary visitor. It was a cipher, a fleeting enigma, a fragment that defied the neat expectations of the solar system. And in its resistance, it revealed a truth far larger than its size. The universe does not yield its secrets easily, and sometimes what it reveals is the magnitude of what remains unknown. NASA's Deep Space Network, usually devoted to listening to distant spacecraft, trained its antennas on the newcomer. No signal arrived, yet the act of listening alone underscored the gravity of the situation. If there was even a remote chance of something anomalous, something beyond ordinary physics, the scientists knew they could not overlook it. SETI, the search for extraterrestrial intelligence, joined in, sweeping its sensitive arrays for even the faintest whisper of communication. Silence answered, but silence itself carried weight. Telescopes and detectors are instruments built to resolve, to clarify, to make the unseen known. Yet, Atlas returned ambiguity. Its dim light contradicted expectations. Its spectral traces dissolved into noise. Where activity was anticipated, there was none. Nights of observation captured photons in meticulous detail, yet the object's nature remained elusive. Scientific vigilance, intended to pierce uncertainty, only revealed deeper layers of it. Each careful observation hoped to find something ordinary, a comet's tail, a cloud of vapor, a familiar spectral pattern, but the visitor refused to conform. The scientific community found itself divided between exhilaration and unease. Every new measurement sharpened the outline of human understanding, sketching the arc of a traveler from the stars. Yet simultaneously, the sketch refused to resemble anything recognizable. As telescopes and surveys focused, the object seemed almost to withdraw, as if its true essence was deliberately elusive. Night after night, instruments strained, calculations multiplied, and debates flared in laboratories worldwide. Vigilance was unwavering, yet it could not mask the sense that sometimes the universe responds in kind, offering puzzles rather than certainty, whispers rather than clarity. Patterns began to emerge in the data, faint but persistent. Its brightness rose and fell irregularly, hinting at rotation, but never settling into a stable rhythm. Astronomers are accustomed to rotational light curves. Spinning asteroids or comets brighten when reflective surfaces face Earth and dim when darker regions rotate away. Atlas, however, moved unpredictably, as though tumbling through space in chaotic motion. Its irregular light variations suggested more than shape alone. Perhaps it was jagged, asymmetrical, a fractured fragment whose surfaces glinted at unpredictable angles. Spectral analysis revealed additional anomalies. Photons collected over weeks showed no clear chemical markers. Comets usually broadcast water vapor, carbon dioxide or organics. Asteroids display silicates or metals. Atlas offered none of these assurances. Its spectrum murmured half-formed notes, resisting classification. It was neither clearly comet nor convincingly asteroid, occupying a grey area in astronomical taxonomy. Each observation of incompleteness amplified the sense of mystery. Some proposed explanations rooted the anomalies in its long journey across interstellar space. Radiation could have transformed its surface into exotic materials, unlike anything in the solar system. Others suggested it was once larger, now shattered, with uneven surfaces scattering light in unexpected ways. More cautious minds considered the darkest possibility. What if these irregularities were intentional? Could some aspect of design or origin, rather than mere chance, explain the perplexing features? NASA's analysts, experts in extracting clarity from faint signals, found themselves navigating uncertainty. Early anomalies became persistent whispers, threading through every recalculation, every adjustment of brightness, every plot of its orbit. The more data collected, the less the object yielded certainty. Instead, its strangeness grew, reinforcing the paradox that observation can magnify mystery rather than resolve it. Anomalies are the doorway to discovery, yet they also unnerve. They reveal the limits of comprehension. In Atlas, the irregularities were neither loud nor definitive, yet they were insistent. They pressed against assumptions, forcing observers to confront a universe that does not always fit tidy categories. Every measurement emphasized what it refused to disclose, transforming a simple interstellar fragment into a riddle, challenging even the most disciplined scientific minds. The visitor behaved almost familiarly, yet never fully aligned with expectation. Its faint light and erratic reflections made it clear the universe had placed something in our path that resembled known objects only in outline. The more closely its orbit was tracked, the stranger the details became. Gravity, that steadfast law shaping planets, comets and asteroids, should have dictated its every curve. Objects falling toward the sun follow precise, predictable acceleration patterns, their paths charted for centuries. Yet Atlas refused to comply. Every calculation, every plotted coordinate revealed minor inconsistencies, subtle deviations that hinted at forces or conditions beyond normal comprehension. Its hyperbolic trajectory, combined with its irregular light and ambiguous spectrum, suggested a visitor whose behavior could not be neatly folded into pre-existing categories. No pattern of motion, no spectral fingerprint, no rotational rhythm confirmed its familiarity. Even as instruments strained, the object retained an aura of quiet defiance. It was not hostile, nor did it radiate signals, yet it radiated something else. A reminder that the universe is broader, older, and more intricate than our models assume. Every flicker of light, every momentary spike of brightness was data, yes, but also a question. Its very presence demanded humility. Human understanding, for all its power and precision, is only partial when faced with a fragment that has traversed millions of years and countless light-years of space. 3I divided by Atlas was no ordinary interstellar stone. It was a ghost of ancient events, a traveling cipher whose story was written in momentum, surface and light. Its paradoxical behavior, silent, irregular, elusive, transformed it from a mere rock into a symbol of the unknown. The universe, it seemed, had placed a puzzle in our skies, and the act of studying it only deepened its mystery. Observation amplified intrigue, and every new insight revealed new contradictions. Astronomers whispered questions in hushed tones. What is it? How did it survive its journey without shedding telltale signs? Does it carry traces of processes unknown to science? The more carefully the visitor was studied, the more ungraspable it became. Data became poetry, ambiguity became caution, and silence became an active presence in every discussion. Its orbit, while measurable, remained enigmatic. Even hyperbolic trajectories, when calculated precisely, hinted at forces or histories that no terrestrial experience could explain. Its motion confirmed its interstellar origin, yet in confirming this, it revealed how little humans can predict when an object comes from beyond the sun's domain. And in its quiet defiance, it reminded observers that understanding the cosmos is less about control and more about adaptation to its unyielding complexity. 3I divided by Atlas had arrived as a faint speck, yet it had already reshaped perspectives. It was at once a scientific object and a philosophical reflection, illustrating that knowledge often arrives with questions that outpace answers. No signal, no plume, no clear spectrum, yet in its elusiveness lay the story of scale, of patience, and of the limits of observation. Its presence demanded respect, even as it resisted comprehension, a silent teacher of humility in the face of the vast inscrutable universe. At first, the deviations were barely noticeable. Tiny differences between calculated positions and what telescopes actually recorded. Some dismissed them as routine noise, the natural fuzziness of even the most precise instruments. Yet, as observations stacked over nights and weeks, the anomalies became undeniable. Its trajectory hinted at forces beyond the simple pull of the sun, as if the star's gravity alone could not account for every subtle twist in its path. A memory stirred among the astronomers. Oumuamua, the enigmatic visitor, whose puzzling acceleration had sparked years of debate, could solar radiation, nudging against an oddly shaped object, explain its movement? Could undetectable outgassing have provided a hidden push? Neither explanation felt complete. Now, with 3I divided by Atlas, the same uncomfortable question emerged. Some suggested the object's form, elongated, perhaps fragmented, could cause these subtle shifts. Others proposed tiny jets of vapor, too weak to be resolved, might exert a gentle influence. Yet, the lack of any visible comet-like activity rendered these explanations fragile. What force was at work? In the equations, these anomalies pressed unease. Science depends on balance. Predicted motion should match observation, and every mismatch is a crack in certainty. Each discrepancy whispered that our understanding of the cosmos might be incomplete. Perhaps nothing extraordinary was at play, only a combination of effects yet to be measured. Or perhaps something far deeper was unfolding. A glimpse of forces unrecognized, hints of a cosmic story beyond even Einstein's reach. For those watching, this gravitational puzzle wasn't about immediate danger. it was about meaning. If universal laws could not fully account for a lone interstellar wanderer, what might that imply about the universe's hidden framework? Gravity, long considered absolute, binds stars, sculpts galaxies, and choreographs the dance of planets. To encounter a drifting exception was a shock to that perception. 3I divided by Atlas moved on, indifferent to human theories, each observation confirming its freedom, each calculation reaffirming its strangeness. The riddle lingered like a shadow on equations, a reminder that shadows in science often mark the presence of something vast just beyond the light. Delving deeper, astronomers confronted a spectral puzzle equally confounding. Normally, sunlight reflected from an object carries chemical clues. Spectroscopy identifies water vapor, frozen carbon dioxide, silicates, metals, organics, each leaving a distinct mark. With Atlas, those marks fractured into near invisibility. Signals were inconsistent, fading in and out like a whispered message. Glimmers hinted at compounds, only to vanish in noise. Reflections suggested materials too complex to classify, or entirely unknown. Its chemistry became ghostly, more absence than substance. Even stranger were the fleeting angles of reflected light. Occasionally it sparkled sharply, suggesting surfaces unusually flat, catching sunlight as though they were faceted rather than rough. Confirmation remained elusive, yet the idea lingered. Could some of its surfaces be unnaturally smooth? Some researchers quietly entertained the possibility. The phrase, unnatural echoes, seeped into conversations, subtle, almost whispered, a dangerous intersection of data and imagination. Explanations were proposed. Cosmic rays over millions of years could have transformed its surface, baking it into materials foreign to the solar system. Catastrophic collisions could leave fractured surfaces, scattering light unpredictably, yet the evidence refused to converge. Whispers of something even stranger began circulating. Not in official papers, but in cautious, late-night discussions. Could the reflections hint at deliberate construction? Panels, sails, engineered layers. The suggestion was seldom voiced publicly, yet privately, some admitted the thought crossed their minds. Its silence, combined with these fleeting glints, posed questions too vast to ignore. Science, grounded in skepticism, naturally resisted such speculation. Researchers pointed to instrument error, gaps in observation, and the human tendency to perceive patterns where none exist. Or had provoked similar debates, but the mere need to argue against the extraordinary revealed the depth of unease. A normal comet would have silenced debate with a tail. A typical asteroid would offer clear spectral fingerprints. Atlas did neither. The anomalies endured, faint and ambiguous, impossible to confirm, yet impossible to ignore. The visitor became a mirror reflecting human curiosity and anxiety, photons interwoven with fear and wonder. Equations, designed to provide certainty, instead became a source of disquiet. Each attempt to model trajectory, light curves, and composition revealed new inconsistencies. For scientists trained to find order in motion, these discrepancies were disconcerting. Fear was not of impact. Atlas posed no threat, but of meaning. Minor mismatches, unresolved accelerations, subtle deviations, all hinted at missing pieces, hidden variables, unrecognized forces. In astrophysics, fear wears a quiet face. It emerges when logic falters, when Newtonian clarity and Einsteinian relativity fail to encompass observed reality. That abyss loomed over those who studied. 3I divided by Atlas. Was it simply an irregular fragment, its strangeness an artifact of imperfect measurement, or was it a messenger, hinting that human understanding of physics is incomplete? Its anomalies grew more pronounced when compared with predecessors. Oumuamua had already unsettled assumptions, and each new discovery of Atlas reinforced the sense that interstellar visitors might routinely defy expectation. The irregularities in trajectory, the spectral silence, the fleeting reflective glints, all these whispered that the cosmos still hides truths our models cannot yet capture. Observation became a test of both technology and imagination. Advanced telescopes, precision instruments, and adaptive optics strained to detect faint signals. NASA, alongside global observatories, tracked every flicker, plotting arcs of light with increasing precision. Yet the more carefully it was studied, the more enigmatic it remained. Each refinement confirmed the object's unbound nature. Each analysis suggested complexity beyond ordinary matter. Atlas' path offered no comfort of familiarity. It was a ghost in the solar system, a traveler whose motion defied complete explanation. Every calculation, every light curve, Every spectral reading layered uncertainty atop uncertainty. Yet this very elusiveness was its message. The universe does not yield easily, and understanding is often a dialogue with silence. In that silence, astronomers confronted the profound. Here was an interstellar visitor, modest in size, yet vast in implication. Its subtle deviations hinted at hidden forces, its irregular reflections suggested alien chemistry or geometry, and its trajectory challenged assumptions about gravitational absolutes. 3I divided by Atlas had become more than a cosmic rock. It was a mirror reflecting not just the nature of the universe, but the limits of human comprehension, the fragility of certainty, and the tantalizing possibility that the cosmos still holds secrets beyond reach. Oumuamua had defied expectations, moving in ways that no visible force could explain. Borisov had appeared more familiar, resembling a conventional comet, yet subtle irregularities marked its journey. And now, 3I divided by Atlas sailed through the solar system, with a quiet insistence on being different, resisting all attempts at categorization. 3 arrivals, 3 enigmas. Coincidence seemed less plausible with each observation. A pattern appeared to be emerging, one that unsettled even the most cautious minds. For some scientists, the unease came not from the objects themselves but from the questions they provoked. What if these wanderers were not mere fragments of distant worlds? What if the slight deviations in speed, the strange reflections were not natural but intentional? The idea was dangerous to voice publicly, risking ridicule or dismissal. Yet in private, the possibility pressed heavily on certain minds, a persistent weight that refused to lift. Others speculated differently, fearing that the anomalies hinted at forces woven into the very fabric of the universe. Could subtle interactions between matter and the quantum vacuum manifest only under such extreme conditions? Could dark energy, the enigmatic driver of cosmic expansion, influence these bodies in ways never before recognized? If so, then 3I divided by Atlas was more than a curiosity. It was a crack in the foundation of known physics. In equations, fear manifests quietly. It does not scream but lingers, a persistent note held too long in the background of an otherwise orderly composition. The object became a reminder that the cosmos does not conform entirely to human expectation, that even the laws we hold sacred may be approximations, fragile nets cast over a reality too vast to fully contain. As the fragment continued its unbound flight, the uncertainty followed, constant and unrelenting. For scientists, certainty provides a kind of safety. To lose it is to glimpse the abyss, and Atlas offered nothing but that abyss, carved directly into the heart of predictive equations. Speculation, in scientific circles, is a treacherous current. It begins as a whisper, a tentative thought that arises in the gaps between measurements. But when anomalies persist and equations refuse closure, the whisper grows. In the case of 3I divided by Atlas, some of those whispers bore the shadow of intelligence. The notion was not unprecedented. In 2017, Oumuamua had sparked similar conjecture, a body with an unexplained acceleration, an unusual form, a silence where activity should have been. Some researchers had cautiously suggested it could be a light sail, a thin structure propelled by starlight, perhaps a remnant of an alien probe. Most dismissed the idea, favoring natural explanations. Yet the notion lodged itself in collective memory, both in the public imagination and the private uncertainties of some astronomers. With Atlas, those lingering doubts resurfaced. Its reflective irregularities, erratic rotation, and refusal to produce a cometary tail echoed the mysteries of its predecessor. Could it be artificial? Could it be a relic, drifting for eons, a piece of technology long abandoned but still crossing the solar system? If so, did it serve a purpose, to observe, to study, or merely to wander? NASA, as an organization, did not support these conjectures, yet within the scientific community, the possibility could not be entirely dismissed. SETI instruments trained their ears toward it, listening for any faint signal. Nothing was detected. Still, silence did not close the door on speculation. After all, what if it was not transmitting? What if it had been wandering for millions of years? Its purpose long since completed, its creators vanished into the depths of time. The potential of intelligence was unsettling, not because of danger, but because of reflection. To contemplate it was to confront humanity's place in the cosmos. If other minds had once shaped fragments and sent them across interstellar space, our assumptions of centrality and uniqueness would be challenged. A discovery of this kind would not only expand our understanding of life in the universe, it would simultaneously diminish our self-perceived primacy. Atlas, silent and glinting, offered no confirmation, yet the mere possibility hung over the observations like a shadow. As data accumulated, the memory of Oumuamua became unavoidable. Its trail of unanswered questions still lingered, fresh and unresolved. Atlas, in comparison, appeared as a spectral sibling, different in detail, yet similarly defiant of expectation. Both followed hyperbolic trajectories, both glided silently where activity might have been predicted, and both carried spectral patterns that refused easy classification. The similarities were striking. Oumuamua had traveled without a halo, without a cometary tail, and had accelerated unpredictably. Its light curve hinted at elongation, unlike anything catalogued within our system. Debate still raged. Was it a fragment of ice, a shard of a shattered exoplanet, or provocatively, a relic of technology drifting through space? Its departure left speculation but no certainty. Then Atlas arrived. At first glance it seemed less dramatic, its brightness steadier, its motions less capricious. Yet the resonances with Oumuamua, undeniable. Its hyperbolic flight confirmed it as an interstellar wanderer, indifferent to the gravitational confines of the sun. Its silence mirrored its predecessors, and its spectral signature dissolved into ambiguity, defying categorization. The body was neither a comet in the classical sense, nor a typical asteroid. Its reflective patches, chaotic rotation, and irregular shape all suggested something that resisted conventional explanation. Each night, astronomers refined models and traced its light curve, yet the object continued to evade certainty. Every observation seemed to deepen the puzzle. Instruments measured brightness, shape, and orbital arc with meticulous care, yet none provided clarity. Atlas became a ghost in the data, its essence revealed less by what it displayed than by the silence and inconsistency it maintained. The spectroscopic analysis proved equally confounding. Sunlight bouncing off its surface yielded no clear chemical fingerprints. Lines of water vapor, carbon dioxide, silicates or metals, typically observable in comets or asteroids, remained absent or faint and inconsistent. It seemed to speak in incomplete notes, a language of photons that refused translation. Occasional glimmers suggested unusual reflective properties, angles sharper than natural surfaces should produce, but confirmation was impossible. Some surfaces appeared nearly flat, catching light in ways that defied the randomness expected from natural rock. The evidence teased observers, a riddle written in flickers of faint starlight. Private conversations in observatories' quiet rooms often touched the unspoken idea. Could it be artificial? Could some of the glints and angles indicate design? The notion was never voiced in formal papers, yet it persisted in the thoughts of a few cautious minds. The object's silence and peculiar reflections offered a persistent invitation to imagine. Natural explanations remained possible: radiation, collisions, or interstellar weathering, but the irregularities were enough to provoke curiosity beyond standard models. Amid the data, the ambiguity persisted. The object's small size relative to planets belied the enormity of the questions it raised. Every anomaly suggested hidden forces, unexpected materials, or previously unrecognized physics. Its hyperbolic trajectory and its spectral silence both signaled that our understanding of celestial mechanics might be incomplete. Atlas had become a mirror, reflecting the limits of human knowledge and the vastness of the universe. Even without confirming artificiality, the shadow of intelligence lingered. Its presence was defined not by proof, but by the possibilities left open. Sometimes, an unanswered question is more compelling, more unnerving, than one with a clear answer. The comparison with Oumuamua intensified the tension. The earlier visitor had unsettled minds, and Atlas, though different in detail, echoed that unease, a phantom twin of defiance. Both suggested that the universe might be filled with anomalies capable of challenging our most basic assumptions about nature, physics, and perhaps even life beyond Earth. Two objects, years apart, each resisting easy classification. Borisov, the second interstellar visitor, had seemed almost conventional, a comet with a luminous tail, behaving predictably, but framed between Oumuamua and 3i divided by Atlas. It now felt like the exception rather than the norm. If two of the three travelers were peculiar, perhaps peculiarity was the rule. Scientists quietly began to speak of a phantom twin. 3i divided by Atlas was not Oumuamua reborn, yet it carried the same haunting echo. Every irregular flicker of reflected light, every spectral silence seemed to replay the earlier enigma, not in exact repetition, but in variation. Like a composer returning to familiar notes in a darker key, the cosmos appeared to challenge observers with a recurring theme. Was this the hint of a broader population of interstellar wanderers, unknown until now? Were these fragments more common than previously imagined, each carrying alien signatures unfamiliar to our solar system? Or was it merely coincidence? Two rare anomalies appearing within decades, their strangeness amplified by timing alone. The public found the connection irresistible. Headlines whispered Oumuamua the moment Atlas was first observed. The idea of a spectral sibling, another alien messenger, another riddle from the void, captivated imaginations. NASA counseled restraint, warning that speculation must not outpace observation. But among researchers, caution could not erase the thrill or the unease. Atlas was Oumuamua seen through a distorted lens. Its phantom twin did not solve the first puzzle. Instead, it doubled it, made it impossible to dismiss. In this duplication lay a creeping fear. Humanity might not be facing isolated incidents, but the opening measures of a grander, darker symphony drifting through space. By this point, the catalogue of anomalies surrounding Atlas had grown long enough that conventional explanations strained at their limits. Theories multiplied, each attempting to weave the disparate threads of data into coherence. None fit without tension. Conceptual turbulence filled the scientific discourse as mathematicians and physicists invoked the great frameworks of modern physics in attempts to anchor what otherwise seemed uncontainable. Einstein's general relativity was first to be tested. In its elegant description of gravity, Atlas's trajectory should have been predictable. Yet small deviations lingered, subtle mismatches clinging to the orbit like shadows. Could it be that these wandering objects were revealing subtle imperfections in spacetime itself? Were our equations only approximations of a more intricate reality? If so, Atlas was no mere stone. It had become a probe of relativity's limits, a wandering test particle in regions where space itself might differ from expectations. Quantum mechanics soon entered the discussion. On the smallest scales, the vacuum seethes with fluctuations, ghostly fields that appear and vanish in the blink of a cosmic eye. Could interstellar journeys across such restless fabric alter matter in ways unseen in our local system? Perhaps Atlas' surface bore the record of these quantum seas, a texture sculpted by invisible forces yet to be measured. Some scientists speculated further, invoking the early universe itself. Cosmic inflation, the blistering expansion that shaped space in its first moments, might have left imprints on fragments drifting since creation. If so, Atlas was not merely a visitor from another star. It carried whispers from the dawn of time, relics of forces unimaginably ancient. Theoretical debates surged. Every framework of physics is simultaneously map and cage. Relativity explains gravity, until it doesn't. Quantum mechanics explains particles, until they vanish. Between them lies a chasm, home to dark matter and dark energy, phenomena known only by their effects, invisible to direct observation. Could Atlas have stumbled into that chasm, carrying hints of forces as yet unnamed? Discussions raged, papers circulated, conference calls crackled with competing interpretations. One faction insisted that natural processes sufficed: erosion, radiation, collision, geometric coincidence. Another, quieter but persistent, suggested the persistence of anomalies pointed to something deeper. Theories collided like particles in a high-energy collider, sparks flying but no lasting synthesis emerging. This turbulence was not failure, it was necessary. In science, contradictions are the crucible of discovery. Atlas, indifferent and silent, had become such a crucible. Its refusal to conform drew gravity, quantum fields, and cosmological expansion into a single discourse, reminding physicists how far they remain from a unified theory. Yet beyond the mathematics lingered an even more unsettling thought. Perhaps the object was not anomalous at all. Perhaps it was the universe itself that is stranger than the frameworks we construct. If so, Atlas was not the exception. It was the standard, and it was our expectations that were anomalous. Among the many hypotheses for Atlas, one grew increasingly compelling, both elegant and unnerving. Its strangeness might be tied to dark energy. The very notion is disquieting. Dark energy is invisible, detectable only by the vast acceleration of the cosmos it governs. Accounting for nearly 70% of all existence, it is inferred, ghost-like, from the motion of galaxies. To suggest it could influence a single interstellar fragment is audacious, but perhaps not impossible. If woven into the fabric of space itself, could dark energy subtly guide objects drifting across the galaxy? Could Atlas, over millions of years, bear faint imprints of that influence, accelerations too slight to reconcile with Newton, reflections too strange to match known minerals? This possibility unsettled researchers, because it shifted the source of the mystery. The question was no longer solely about the object itself, but about the cosmic environment surrounding it. Atlas became both traveler and messenger, a silent interlocutor whispering the limits of understanding. In this, the fragment transcended its modest size. It was no longer merely a celestial object but a probe of the universe's hidden structure, a fragment whose existence hinted that the cosmos itself might defy all tidy categorization. If 3I divided by Atlas was subtly guided by dark energy, then every celestial body, every star, planet, and speck of cosmic dust was caught in the same unseen current. Its oddities would not be unique, they would be a universal echo, a reminder that much of reality unfolds beyond human perception. Ideas began to multiply. Some theorists imagined interstellar fragments acting as natural detectors of dark energy, their trajectories bending in ways that could reveal hidden properties of the cosmic expansion. Others ventured further, proposing that certain anomalies might hint at local fluctuations in the energy field, pockets where the stretching of space was uneven. In this view, Atlas was no mere wanderer from another system. It was a messenger, carrying news of the very scaffolding of existence. Yet this speculation carried a darker undertone. If dark energy dominates the universe, it shapes not only motion but destiny. It will drive galaxies apart, silence stars, and stretch spacetime until everything familiar dissolves. To glimpse its subtle influence in the trajectory of a single rock was to see a distant future miniatured in motion. Most astronomers treated such connections as tenuous, unproven. Yet the very act of considering them revealed how profoundly Atlas had unsettled scientific thought. A normal comet or asteroid would never have inspired such reflections. Only something that defied classification, something whispering of the impossible, could push minds to consider that the universe's most profound mysteries might be inscribed in the drift of a solitary fragment. Atlas became more than a celestial object. It became a lens through which humanity confronted ignorance, a fragment of interstellar silence inviting thoughts of expansion, decay, and the invisible forces tugging at the cosmos. From dark energy, speculation expanded outward. Some physicists began to ask an audacious question: what if Atlas did not originate from our universe at all? The notion seemed nearly heretical, yet it emerged naturally amid the turbulence of unanswerable questions. Inflationary cosmology, describing the universe's earliest moments as an eruption of exponential expansion, predicts that other universes could bubble forth from the quantum vacuum. Each would have its own laws, constants, and histories. Could Atlas be a fragment expelled from such a neighboring universe, drifting across a fragile boundary into ours? Its anomalous orbit, silent spectrum, and unclassifiable reflections might be exactly what one would expect from matter forged under unfamiliar laws. Few embraced this idea outright, but its logic could not be dismissed entirely. If universes exist beyond our own, some interactions between them seem inevitable, and fragments could wander across boundaries, carrying the chemistry of alien physics. For those willing to imagine, the implications were staggering. Atlas would not signal intelligence or technology, it would testify to the vastness of reality itself, a fragment demonstrating that the laws we take as sacred may be local conventions within a grander multiversal archipelago. Its silence, then, was not refusal but testimony, a mute proclamation that we are not alone in space, nor perhaps in existence. Even more unsettling was the possibility of a false vacuum. This is not science fiction, but a mathematical scenario emerging from quantum field theory. It posits that our universe might be perched precariously in a temporary energy minimum, stable only in appearance. A deeper, truer vacuum could exist, and if triggered, would collapse everything we know. A bubble of this true vacuum would expand at light speed, rewriting physics as it devoured reality, leaving no warning and no escape. Some scientists allowed themselves to wonder, what if Atlas's peculiar path and spectral silence hinted at matter shaped under an alternate vacuum? Could it be a shard cast from a region of space where physics had already shifted, carrying the imprint of altered laws? In this light, Atlas ceased to be a mere curiosity. It became a harbinger, a fragment holding the faint shadow of a universe stranger and larger than we could fully grasp. Its quiet defiance of expectation forced scientists to confront not only the limits of observation but the fragility of all certainty. If 3I divided by Atlas carried even a trace of evidence pointing to false vacuum instability, its passage was no ordinary celestial visit. It became a quiet warning, the universe might be far less stable than humanity assumes, and someday, without notice, that fragility could reach us. Most researchers dismissed such thoughts. They were leaps of imagination, not grounded in evidence. Still, the idea lingered, because the scenario was physically conceivable. False vacuum decay is a legitimate, if remote, possibility in modern physics, and Atlas, with its defiance of expectation, became the perfect vessel for such speculation. In observatories, the idea whispered through corridors and between telescope domes, rarely voiced aloud. Could this be a messenger from a region where the very laws of physics have shifted? Even if improbable, the thought carried a weight, reminding humanity of its vulnerability and of how tenuous our certainties truly are. For if the false vacuum hypothesis were real, everything, atoms, planets, galaxies, life itself, rests on a fragile balance, capable of disappearing without warning. Atlas, silent and unyielding, became the symbol of that precariousness, a fragment drifting inward from the margins of existence, carrying with it a suggestion that reality itself might be impermanent. Silence can unsettle more than sound. When Atlas was confirmed as interstellar, one of the first questions was whether it might broadcast any signal, a ghost of intelligence traveling on invisible waves. If its peculiarities hinted at something beyond the ordinary, perhaps the ultimate test was to listen. SETI responded quickly, aiming radio arrays at the patch of sky. Atlas traversed, scanning across frequencies for any whisper of pattern or purpose. Expectations were low. Interstellar visitors are assumed lifeless, yet the unusual behavior of Oumuamua had seeded caution, and Atlas shared enough similarities to justify vigilance. Night after night, arrays swept the sky. Static remained unbroken, signals absent, no narrowband bursts, no repeating pulses, only silence. But silence is not confirmation of emptiness. A probe, abandoned or dormant, might lie quiet for millennia, its systems expired or its design inscrutable. The quiet left a space for imagination, a shadow hovering over the question of intent. Optical searches followed. Scientists looked for flashes, reflective glints, or laser-like emissions that might suggest controlled activity. Again, nothing. The absence weighed heavily, not because it proved anything, but because it suggested restraint, deliberate or not. Comets blaze with tails, asteroids reflect with known mineral signatures, but Atlas remained inscrutable. Its spectrum dissolved into ambiguity, its brightness oscillated erratically, its composition refused identification. Rationally, these traits could be natural. Cosmic rays, collisions, radiation, and sheer chance could shape unfamiliar fragments. Yet the idea that the silence might be meaningful, the possibility of intentional absence, refused to vanish. The emotional resonance was as potent as the scientific. Humanity has always wondered whether it is alone. Each anomaly rekindles that yearning. Instruments strained, searching for a voice, and found only emptiness, a void that imagination eagerly filled. Atlas offered precisely such a void, a silence echoing with both awe and unease. It did not answer questions, it deepened them. In mystery, silence becomes reflective, showing not what exists but what we fear or hope might. Obsessive attention followed. Every telescope capable of tracking it was turned skyward, for the object's passage was fleeting. Hubble, despite approaching the twilight of its service, trained on the visitor, capturing points of faint light against the stellar backdrop. Observatories worldwide contributed. The Atacama Desert, Hawaii, and other sites combined their data to refine trajectories, rotation, and brightness curves. Even then, Atlas resisted definition. Its flickering light curves contradicted themselves, never settling into predictable patterns. Finally, James Webb Space Telescope joined the hunt. Designed to peer into the earliest galaxies and exoplanet atmospheres, Webb now turned its golden mirrors inward, toward this closer, enigmatic traveler. Infrared analysis sought signatures invisible to optical instruments. The results remained inconclusive. Spectral lines were faint or irregular, hints of material that defied categorization. It was as if Atlas spoke in a dialect of matter, alien to the solar system, a language no human instrument could fully translate. The pursuit of understanding Atlas extended far beyond traditional telescopes. Observatories around the globe trained their lenses, but also their computational arrays, attempting to trace even the subtlest variations in its movement across the sky. Radio facilities, tuned to detect the faintest artificial signal, continued their vigil, listening through static for patterns that might hint at intelligence. Yet, night after night, the universe remained quiet. The global scientific network, spanning continents and disciplines, cooperated in a rare convergence of effort. Every instrument aimed at a fleeting visitor that would soon vanish into interstellar shadows. And yet, despite the magnitude of human ingenuity marshaled against it, clarity remained elusive. Every new observation seemed only to sharpen the contours of mystery, revealing not answers, but the object's persistent opacity. Atlas drifted through space with a quiet defiance, a small fragment perhaps no larger than a modest mountain, yet capable of withstanding the scrutiny of Earth's most powerful instruments. For some researchers, this resistance offered comfort, a reminder of the vastness of the cosmos and the inexhaustible reservoir of questions it contains. For others, however, it sparked unease, even apprehension. If so much effort could produce so little understanding, what of the countless other enigmas that surely traverse the galaxy unseen? The object's silence was stubborn, unyielding, a refusal to conform to the frameworks that govern comets, asteroids, and interstellar debris alike. It left humanity with glimpses, footprints in cosmic sand that hinted at presence but never fully revealed it. While telescopes traced Atlas's dim light across the heavens, another community of scientists turned to different tools: particle physicists, accustomed to probing the fundamental constituents of matter and energy, began to wonder if the anomalies of this interstellar wanderer might be approached not only through astronomy, but through high-energy collisions and the study of quantum fields. In facilities such as CERN, the universe is recreated in miniature. Beams of protons slam together at energies reminiscent of the first moments of creation. Could Atlas's peculiar behavior, its irregular acceleration, its spectral ambiguity, its refusal to manifest expected cometary activity, be understood through such collisions? The parallels were tantalizing. The surface of Atlas could conceal atoms forged in alien conditions, exposed to processes that had no equivalent in the solar system. Perhaps its unusual motions were imprinted by rare or exotic elements, formed in the cataclysmic collapse of a distant supernova or the violent merger of neutron stars. Some theorists proposed that the object's behavior might reflect interactions with the quantum vacuum itself, a subtle interplay of fields and forces invisible to ordinary matter, exerting minute but persistent effects over its interstellar journey. In this sense, particle accelerators became laboratories not only of verification, but of speculation, probing the potential microphysics behind a cosmic anomaly. Yet there were darker, more unsettling possibilities. Could Atlas's erratic acceleration be powered by internal reservoirs of volatile compounds, materials alien to our solar system, storing energy in ways unknown to earthly chemistry? If such compounds reacted under the right conditions, their release might mimic cometary outbursts or create phenomena entirely unfamiliar. Perhaps, some suggested, Atlas was not a passive stone at all, but a vessel carrying chemistry sculpted elsewhere, a messenger encoded in elemental form. The notion of collisions extended further still. Atlas could itself be the product of cosmic violence, a fragment torn from a young planet in a distant system, ejected with tremendous force, and sent drifting for millions of years through the void before arriving in our solar system. Its irregular flickers of light, its glints and flashes, could then be interpreted as the fractured testimony of that ancient cataclysm, the last echoes of a world humanity would never witness. In this context, the language of high-energy collisions became a metaphor bridging scale, the infinitesimal interactions of subatomic particles mirrored in the vast energetic chaos of planetary destruction. Atlas occupied a liminal space, a particle in the theater of astronomy, carrying within it the potential to reveal physics written in a dialect alien to our instruments. Despite these models, none provided definitive answers. The object's silence remained steadfast, indifferent to human speculation. Particle physics could suggest analogies, frameworks for understanding, but Atlas itself resisted explanation. It was as if the cosmos had presented a riddle too vast for accelerators, too fleeting for telescopes. Yet, this resistance was not wasted. Chasing Atlas's anomalies forced science outward, connecting phenomena across scales from the microcosm of particle interactions to the macrocosm of interstellar travel, from collisions in accelerators to collisions of worlds. In this synthesis, a profound lesson emerged. The universe is a continuous fabric stitched together from the minute and the immense, the quantum and the cosmic. As months passed, a sobering truth settled over the scientific community. Certainty was slipping away. The sunward swing had passed. Atlas had moved through the inner solar system, and now it was receding into the black. Observations continued, yet clarity remained out of reach. This marked the edge of empirical understanding, the point where precise measurement gives way to speculation. Astronomy, a science of distance and faint light, often constructs knowledge from fragments, but here, the fragments were too few, too contradictory. The light curve hinted at rotation, yet no consistent pattern emerged. Spectral analyses suggested familiar minerals, then dissolved into ambiguity before confirmation could be made. Even the trajectory, examined with utmost precision, revealed slight deviations, inconclusive for rewriting the laws of motion. At this threshold, humility grew. Recognizing uncertainty was not weakness, but an acknowledgement of the cosmos's scale. Yet humility did not erase discomfort. Scientists are trained to extract signal from noise, to resolve ambiguity into clarity. When the noise persists and the signal slips away, it is experienced as both professional frustration and existential unease, a reminder that knowledge is provisional, that the universe guards its secrets. Consequently, the language of publications grew cautious. Perhaps, likely, tentative, these qualifiers filled journal pages, reflecting both diligence and restraint. The global observational effort encompassed multiple instruments. Hubble, though nearing the end of its service, recorded Atlas's faint glimmers against a backdrop of stars, each photon precious. Ground-based telescopes contributed as well, from the thin, dry air of Chile's Atacama Desert to Hawaii's lofty peaks, supplying crucial optical data. These were combined with survey arrays such as Pan-STARRS and the Atlas network, refining trajectories, rotations, and brightness models. Yet even these collective efforts could not resolve the enigma. The light curves flickered unpredictably, refusing the stable rhythm expected of familiar celestial bodies. Then the James Webb Space Telescope entered the endeavor. Its infrared instruments, designed for distant galaxies and exoplanet atmospheres, were turned toward Atlas. Webb's data offered hints of unusual materials, spectral signatures that defied categorization, lines too faint or irregular to match known substances. Atlas seemed to communicate in a dialect of matter foreign to the solar system, one which human instruments could only partially interpret. Every observation revealed the object's alien character: no cometary tail, no asteroid-like mineral fingerprints, only fragments of information hinting at complexity beyond comprehension. The pursuit of understanding extended beyond observation into theory. Particle physicists pondered whether the anomalies could be explained by interactions at the smallest scales, subatomic forces, vacuum fluctuations, or exotic particles influencing motion over light years. Could these irregularities be the result of material formed under conditions radically different from our own, sculpted by processes undetectable in local laboratories? Collisions in particle accelerators, which mimic aspects of creation on miniature scales, offered a tantalizing metaphor. By observing such events, scientists could explore possibilities that might illuminate the subtle physics behind Atlas's anomalies. Speculation encompassed even more dramatic scenarios. Could Atlas contain exotic matter, heavy elements in ratios unlike anything found in the solar system? Could its peculiar acceleration reflect subtle forces exerted by the quantum vacuum, invisible to ordinary gravitational observation? Was it the remnant of catastrophic planetary collisions, flung across the galaxy with unimaginable violence, a shard from worlds we will never see? In these questions, the scales of physics stretched from the microscopic to the cosmic, a bridge linking subatomic collisions and the violent ejection of planetary fragments. Yet even these explorations did not yield certainty. Atlas remained silent, a persistent riddle that refused categorization. Every attempt to pin down its composition, behavior, and origin met with contradiction. The object's trajectory deviated subtly from predictions, its light curve oscillated unpredictably, and its spectral signatures dissolved into ambiguity. Researchers could offer frameworks, analogies, and models, but none could provide definitive proof. The silence was itself a statement, a reminder that some mysteries exist beyond current instruments, beyond human capacity for immediate comprehension. In this context, the interplay between astronomical and particle physics became vital. Observatories mapped the object's path across the sky. Accelerators explored potential microscopic explanations. Together, they emphasized the unity of nature's laws across scale, from collisions of subatomic particles to the interactions of interstellar fragments. Atlas became a bridge between domains, a demonstration that understanding the universe requires attention to both the infinitesimal and the immense. The cumulative observations brought an unsettling realization. The more Atlas was studied, the more elusive it became. Its passage through the inner solar system, its interactions with solar radiation, its spin, its reflections, its spectral lines, none conformed to expectations. Certainty slipped further away, leaving a community of scientists confronting the limits of measurement. Data flowed in continuously, yet no coherent narrative emerged. Atlas's departure outward toward the void signified that future observation windows would be even shorter, and the object's ultimate nature might remain forever beyond reach. At the edge of knowledge, humility and caution prevailed. Recognizing the limitations of instruments, the provisional nature of models, and the gaps in understanding became essential. The uncertainty did not diminish the endeavor. Rather, it illuminated the vast, intricate complexity of the cosmos. Every photon recorded, every measurement taken, every speculative model offered insight, even if definitive answers remained absent. Atlas, in its silence and defiance, became both a challenge and a teacher, a reminder that exploration is not solely about certainty, but about the relentless pursuit of understanding in the face of mystery. Speculative models, multiplied like stars in the night sky. Was Atlas a leftover comet? A fragment of a shattered asteroid? A chunk of exotic ice? A relic of engineered technology? Or even a shard originating from an entirely separate universe? Each proposal offered insight but came burdened with limitations. No single explanation could unify the observations without contradiction. And so, Atlas joined a lineage of cosmic enigmas that defied full comprehension, a small family of celestial mysteries that science can approach, probe and theorize about, yet may never wholly solve. Its peculiarity was undeniable, its refusal to conform obvious. In the absence of decisive proof, certainty dissolved first into probability, then into pure possibility. What remained was not knowledge, but ambiguity, a persistent reminder that the cosmos resists total understanding. Yet the void left by uncertainty was fertile, not barren. From Oumuamua to Borisov to Atlas, these anomalies have stretched science beyond its familiar borders, compelling researchers to forge connections across disciplines. Cosmology met particle physics, the distant met the infinitesimal. The fragments of interstellar debris prompted consideration of realms once thought improbable. Even if Atlas itself vanished, its questions would linger, shaping inquiry for decades to come. In this way, the object conferred a kind of gift. To confront the limits of certainty is to confront the essence of scientific pursuit, not the accumulation of answers but the relentless drive to ask them. By withholding its secrets, Atlas left humanity with something perhaps more valuable than facts, a reminder of the cosmos's vastness, its inexhaustible mysteries and the limits of human grasp. Inevitably, speculation veered toward philosophy. Atlas was not only a matter of telescopes and equations, it was a question of meaning. Its silence, its anomalies, and its refusal to fit categories stirred ancient contemplations about our place in the universe, the nature of knowledge, and the fragile balance between comprehension and wonder. Scientists are trained to focus on measurable data, to resist philosophical digression, yet history reminds us that the greatest minds navigate both realms. Stephen Hawking, in his reflections on cosmology, repeatedly emphasized that the unknown is not emptiness, but a frontier, and that the laws we take for granted may be provisional scaffolds awaiting revision. Carl Sagan, decades earlier, urged a similar humility, noting the fragility of our home planet and the vastness of space, encouraging awe and careful reflection. Both voices echoed in discussions surrounding Atlas. For some, the anomaly posed a lesson in epistemology, the study of knowledge itself. Why do humans crave certainty so desperately? Why does ambiguity feel intolerable in a universe defined by immensity? Perhaps expecting complete explanation is itself an expression of hubris. Atlas reminded observers that some questions might remain unresolved indefinitely, and that awe need not diminish in the absence of answers. It is sharpened by the unknown. Others found in the interstellar visitor a mirror of myth. Long before telescopes, humanity told stories of wandering stars as omens, messages from the divine, harbingers of change. Modern science replaces myth with mathematics, yet when confronted by an object arriving from beyond the solar system, primal instincts reawaken, the wonder, the curiosity, the sense that the universe is speaking in riddles beyond our immediate understanding. In this sense, Atlas transcended physicality. It became a philosophical challenge. It questioned whether reality is a closed book, patiently awaiting our understanding, or a boundless sea, inherently unknowable. It asked whether human significance is measured by mastery over nature, or by the humility to marvel. The silence of Atlas carried its own message. It was not merely a scientific puzzle, but a reminder that human knowledge is limited. The visitor posed no tangible threat, Its orbit ensured it would pass safely and eventually disappear into the interstellar void. Yet its elusiveness revealed a subtler peril, the danger of blindness. Humanity has historically misread cosmic signs, and misunderstanding once brought famine and fear. Today, ignorance carries new stakes. In a universe where fragments of distant systems may arrive unannounced, failure to understand can have consequences not of superstition, but of miscalculation. What if a future object similar to Atlas were massive, unpredictable, or on a collision course? To confront such an entity unprepared would invite catastrophe. Atlas, in its subtlety, exposed the limits of predictive power. If an object so small could confound instruments, models, and the intellect, what other phenomena might lurk beyond comprehension? The peril of ignorance is not simply what is unknown, but what cannot be anticipated. Its implications extend beyond science to imagination, which in turn shapes collective fear, media speculation about alien technology, or messages inevitably accompanied scientific caution. Ironically, attempts to suppress conjecture often amplified it. The act of denying possibility can validate it in the public mind. Silence invites projection, and in Atlas's case, both wonder and trepidation grew in the fertile soil of uncertainty. Yet some thinkers regarded this ambiguity as a gift rather than a threat. Ignorance, they argued, is the engine of inquiry, the spark of discovery. Without mysteries, science loses momentum. And yet, when the enigma feels overwhelming, even the boldest inquiry can falter, paralyzed by the weight of the unknown. Atlas balanced on this precipice, a knife edge between inspiration and apprehension. Contemplation of Atlas deepened when contextualized against humanity's place in the cosmos. Our species has, so far, mastered only one planet, sending probes to a mere handful of neighboring worlds, observing the universe through instruments that perceive only narrow slices of reality. The object's fleeting passage reminded humanity of the limitations of perception, the tiny window of opportunity to understand even a single fragment traveling across light years. It underscored a humbling truth for all our knowledge. The universe remains immense, its complexity staggering, its secrets largely intact. Atlas also prompted reflection on temporality. Its journey, spanning possibly millions of years, intersected with human observation for only a brief moment. For a few months, researchers could collect data, refine models, and debate theories. Yet for the vast expanse of time, the object remained a silent traveler. In this ephemeral encounter, humanity glimpsed both the magnitude of cosmic timescales and the fleeting nature of its own understanding. The encounter emphasized that knowledge is provisional, and certainty provisional still. Science is a dialogue with the universe, not a declaration of finality. In parallel, the object challenged the boundaries between disciplines. Astronomers catalogued its brightness, trajectory, and spectral signature, while physicists explored the implications of exotic matter, quantum interactions, and vacuum fluctuations. Cosmologists speculated on its formation in distant stellar nurseries, supernova remnants, or even hypothetical multiverse collisions. Each perspective illuminated part of the puzzle, yet none could complete it. Atlas resisted neat classification, reminding all observers that nature rarely conforms to tidy categories. It was both a catalyst and a mirror, forcing science to expand but also reflecting the limits inherent in observation and reasoning. In the absence of conclusive data, the philosophical undertone became more pronounced. Atlas was a reminder that curiosity is not merely about solving equations or confirming hypotheses, but about confronting the unknown itself. To face something inscrutable is to acknowledge human limitation, yet in that acknowledgement lies growth. Scientists learn to navigate humility alongside inquiry, accepting that some aspects of reality may remain beyond comprehension for centuries. In this, the object provided a lesson beyond astronomy, particle physics, or cosmology. It taught epistemic patience, the value of questions without immediate answers, and the richness of uncertainty. Ultimately, Atlas became more than a rock traversing interstellar space. It was a nexus for reflection on science, philosophy, and human existence. Its elusiveness provoked scientific rigor and imagination alike. It served as a reminder that the universe is not merely a collection of objects to be catalogued, but a complex, dynamic arena of possibility, constantly exceeding expectations. Through its silence, irregularity, and resistance to classification, Atlas urged observers to recognize the provisional nature of knowledge, the beauty of mystery, and the humility required to confront both. In the final reckoning, certainty gave way to wonder, probability to contemplation. Atlas left humanity with no answers, yet it conferred something perhaps more profound, the recognition of cosmic vastness. the acceptance of limits, and the reminder that understanding is an ongoing pursuit. The object challenged the notion that science is the acquisition of fixed truths. Instead, it revealed science as a process, one of observation, interpretation, debate, and reflection, a dialogue with a universe that will always exceed comprehension. In doing so, Atlas transformed from a transient interstellar fragment into a symbol of inquiry itself, a testament to the enduring human desire to seek, to question, and to marvel at the cosmos. In the face of such limits, the arrival of an object that defies comprehension feels almost like a reproach. It reminds us that we are still novices at the boundary of a vast forest, peering into darkness with lanterns too faint to illuminate more than fragments of what lies within. The danger of ignorance is not merely practical, it is existential. It underscores how easily understanding can be mistaken for mastery, and how tenuous our grasp is when measured against the immensity of the unknown. Atlas, in its silence, became more than a celestial puzzle. It was a lesson. The greatest peril may lie, not in what we observe, but in what slips past unnoticed, unexamined, unresolved. Though the fragment passed through the solar system harmlessly, the questions it provoked lingered. Its presence suggested the possibility of recurrence. If one interstellar visitor can wander through our skies, followed by another, and then a third, what prevents countless others from doing the same? The inquiry shifted. It was no longer whether more would appear, but when, and in what guise. Astronomers began to imagine a galaxy filled with drifting interstellar remnants, debris ejected during the violent births and deaths of planetary systems. Perhaps Oumuamua, Borisov, and Atlas were not anomalies, but the first hints of a persistent flow of cosmic travelers threading invisible highways across the stars. Humanity, it seemed, was not an isolated observer, but a resident at a crossroads, where the paths of suns intersect silently. This realization inspired awe. Each new visitor could carry secrets of alien worlds, chemical compositions foreign to Earth, or stories encoded in their surfaces, and unease, for not all interstellar visitors would be benign. A large, fast-moving object might one day arrive on a trajectory less forgiving. The scars of Earth's history, the craters and extinctions left by ancient impacts, serve as a stark reminder of such dangers. Beyond physical risk lay an even deeper uncertainty. What if the next arrival is stranger still? Atlas already resisted conventional categorization, already embodied anomaly. If future fragments carry new irregularities, spectral silences or gravitational quirks, the pattern deepens. Each unexplained visitor raises the possibility that these objects are not mere stones, but the byproducts of processes, or perhaps even designs, we have yet to imagine. NASA and other institutions have already responded. Plans for new survey telescopes are underway, instruments capable of scanning the sky more rapidly and sensitively to catch these wanderers before they vanish. Yet, even with heightened vigilance, limits persist. Interstellar objects arrive without warning, drift with indifferent speed, and depart quickly. To intercept one, to send a mission in time, would demand readiness and foresight humanity has yet to achieve. The specter of Atlas's successors is both a challenge and a caution. We may not be prepared when the next visitor arrives. Amid these practical considerations, a philosophical dimension emerges. What if these objects are not entirely random? What if their arrivals follow patterns, rhythms, or purposes beyond our understanding? Pondering such questions takes us beyond science and into myth, a realm that has always lingered on the edge of astronomical observation. A sky populated with wandering fragments is a sky rich with stories, each carrying both wonder and apprehension. Atlas was not a conclusion. It was the beginning of recognition. The solar system is not isolated, not shielded, not immune. It opens onto the galaxy, which does not move silently. Visitors will return, some illuminating, some terrifying, and in their passage, humanity measures itself against the unknown. Observing Atlas also confronts us with scale. For a fragment to travel from one star system to another requires spans of time measured not in human centuries, but in millions of years. Crossing these gulfs demands patience that dwarfs imagination, endurance that exceeds the comprehension of entire civilizations. Against such temporal and spatial immensity, human effort appears fragile. Every calculation carries the weight of this perspective. The solar system, vast though it seems to us, is but a mote within the galaxy. Light takes hours to reach distant planets. To traverse the Milky Way at light speed would take tens of thousands of years. And yet Atlas has done precisely that, not in a single lifetime, nor in thousands, but across epochs that erase civilizations as waves erase footprints in sand. This comparison diminishes human accomplishment. Spacecraft crawl at tens of kilometers per second. Atlas races faster, indifferent to our slowness. Even Voyager 1 and 2, humanity's farthest emissaries, have only recently stepped beyond the solar boundary, and they too will wander millennia before nearing another star. Meanwhile, fragments like Atlas drift effortlessly, carrying their histories without engines, without intention, without urgency. The philosophical implications are profound. Humanity measures time in years. The cosmos measures it in ages. We see centuries. The universe sees instances. Standing beneath the stars, witnessing an interstellar visitor glide silently across the void, this dissonance becomes visceral. Our smallness, the brevity of our span, the narrow reach of our senses. Yet even in this humbling, there is a strange solace. If Atlas endures millions of years of wandering, perhaps the universe itself preserves memory. These fragments may be repositories of vanished events, records of planetary collisions, stellar births, and cosmic destruction that no human will ever witness. They are not merely vast in scale, but narrative in scope, celestial archives drifting across the galaxy, chronicles of existence written in stone, ice, and elemental scars. Each fragment is a testament, a library of cosmic history carried silently across light years, a reminder that the universe is both vast and attentive, indifferent yet persistent, holding stories that demand patience, reflection, and wonder. Even so, the challenge persisted. How could humanity, so small and fleeting, hope to grasp or engage with such vastness? Our telescopes capture only fleeting glimmers, our theories falter when faced with anomalies. Even our language strains, reaching toward oceans, deserts, and shadows to express scales that defy comprehension. The arrival of Atlas did not narrow this gulf, it widened it, a stark reminder that the cosmos is not tailored for human understanding. The fear evoked by this immensity is subtle yet profound. If we are so minuscule, what else traverses the galaxy unseen? If our lives are but brief flickers, what grand dramas unfold while we sleep? Atlas's passage was more than an astronomical event. It was a confrontation with scale itself. To exist as humans is to occupy the smallest rung of cosmic magnitude. Yet paradoxically, that very smallness highlights the significance of our awareness. To detect an interstellar visitor, to name it, to record its fleeting presence, is an act of defiance. Though tiny, we are conscious. In awareness, we assert a role in the unfolding story of the cosmos. The enigma of Atlas revealed more than peculiar motions or spectral anomalies. It exposed the way science confronts the unknown. Each anomaly prompted scientists to develop sharper instruments, refine calculations, and propose bolder hypotheses. In grappling with Atlas, they tested not only theories but the very frameworks of knowledge itself. This became a measure of science: could the tools forged to understand the familiar rise to meet the truly alien? Astronomy has always demanded patience and humility. From clay tablets etched with star charts to sprawling arrays of space telescopes, truth is assembled from faint signals over long stretches of time. But interstellar visitors push this discipline to the brink. They do not linger, they do not return. They appear briefly and vanish, offering only a narrow window before disappearing into the void. Studying them is a contest against time itself. With Atlas, that struggle was evident. Observatories around the world coordinated to capture the subtlest variations in brightness and motion. Orbital models were painstakingly refined, seeking deviations that might hint at unseen forces. Theories proliferated, some cautious, some audacious, each tested against the meager, often contradictory, evidence. This global endeavor exposed science at its most vulnerable and most noble. Vulnerable, because the data could never be complete. Noble, because the pursuit continued regardless. The lesson was unmistakable. Science is not the possession of certainty, but the pursuit of it. Atlas's very strangeness compelled researchers to expand their imaginations, bridging cosmology with particle physics, weaving astronomy, philosophy, and speculation together. Doubt was not weakness, it became a tool, sharpening questions and guiding the search for deeper understanding. Frustration inevitably crept in. If even the combined capabilities of Hubble, JWST, and Earth's greatest observatories could not fully characterize a single fragment, what hope existed for the innumerable mysteries still concealed in the dark? Yet herein lay the essence of inquiry. Progress is rarely in conquering every question, but in enlarging the scope of questioning. Each anomaly opens doors. Each failure to explain marks the frontier of discovery. The test was never whether Atlas could be fully understood, It was whether the scientific community could face uncertainty without retreating into denial or superstition. By confronting the unknown openly, acknowledging gaps and resisting premature conclusions, science demonstrated its resilience. Atlas left unanswered questions, but it also left a legacy: improved methodologies, heightened awareness, and reinforced humility. In this sense, the interstellar visitor was less a riddle to solve than a mirror reflecting science itself, revealing the limits of our instruments, the persistence of human curiosity, and the courage required to dwell within uncertainty. The object departed, but the challenge endures, echoing in every telescope still trained on the night sky. As Atlas receded into darkness, the focus shifted from scientific puzzles to human reflection. The visitor was harmless in its passage, yet its mystery mirrored humanity's vulnerabilities. Often, our greatest fears are not of the object itself, but of what it exposes about us. For millennia, humanity has gazed upward with a mixture of awe and dread. Comets once provoked terror, seen as portents of kings' downfalls or empires' collapse. Meteors were interpreted as divine arrows, celestial warnings hurled into mortal affairs. In the modern age, mathematics replaced prophecy, and physics supplanted superstition. Yet Atlas stirred something older, more primal. It reminded us that the unknown still carries the power to unsettle, not because it threatens directly, but because it reveals the fragility of our knowledge. Its mirror of fear was subtle, yet deep. It reflected the tenuous security of human existence, the realization that the solar system is not sealed, and that objects from the void can intrude at any moment. It exposed intellectual vulnerability, the truth that even our most advanced instruments cannot fully decode a single visitor, and it hinted at existential precarity, the quiet recognition that humanity's place in the cosmos is smaller and more fragile than we dare admit. Yet fear need not paralyze. Interpreted differently, it can illuminate. To be unsettled is to be awakened. If Atlas reflects human vulnerability, it also reflects potential growth. Confronting the unknown cultivates humility. Grappling with anomalies refines tools and methods. Fear becomes a shadow outlining wonder, a darkness that gives definition to light. Scientists, though shaken, understood this. The visitor reminded them that certainty is fragile, that knowledge is provisional, and that even the most steadfast assumptions can crumble when confronted by the alien. Humanity takes pride in mastery over physics, technology, and observation, yet Atlas revealed the limits of that mastery. Its silent passage was not a threat, but a lesson. The universe is vast, unconstrained, and indifferent, and our understanding is always partial. In that partiality lies both danger and opportunity, and in that balance, the spark of curiosity persists. Yet here was a fragment of stone and silence, smaller than a mountain, that defied all attempts at classification. If something so diminutive could unravel our models, what of the greater enigmas still roaming the galaxy, unseen and unknowable? In this sense, 3I divided by Atlas was not merely an interloper, it was a teacher. Its lesson lay not in what it was, but in what it revealed about us. Fear does not arise from impact alone, but from significance. It is born not of danger, but of implication. The mirror it held up reflected humanity's fragility, yes, but also its courage. To tremble before the unknown yet persist in understanding is the essence of science. To confront the unfathomable while reaching outward is the essence of being human. When fear softened, what remained was older, gentler, and perhaps more enduring wonder. In its silence and refusal to fit neatly into categories, 3I divided by Atlas reminded us of the strangeness of existence itself. Awe and mystery are not obstacles to science. They are its lifeblood. Without them, observation is hollow. Numbers alone are sterile. With them, even the faintest flicker of light on a telescope sensor becomes a doorway into meaning. The very qualities that unsettled the mind, the anomalies, the quiet defiance of expectation, also nourished the imagination. Its silence was disquieting, yes, but it was also beautiful. To envision a fragment drifting across the galaxy for millions of years, untouched and unseen until this fleeting moment, is to imagine endurance beyond comprehension. Its anomalies, while frustrating, were gifts. They reminded humanity that the universe is not a finished book but an unfinished poem, with verses written in riddles we are still learning to read. Scientists often speak in data, yet many admit quietly that what sustains them is not certainty, but awe. To glimpse an interstellar visitor is to glimpse the unimaginable, a shard of another sun's story, a relic of a distant world, a messenger crossing the vast gulfs between stars. 3I divided by Atlas carried no words, no tales, no broadcast. yet its silence spoke volumes. It whispered that the universe is larger than our minds can encompass, stranger than our models can render, and richer than our instruments can capture. The public, too, felt the pull of this wonder. Headlines speculated about alien probes, cosmic riddles, and unsolved mysteries. Behind the noise lay something simpler, the joy of witnessing a fragment of the cosmos in motion. For much of human history, the stars were untouchable, eternal, and beyond reach. Now, fragments from those distant lights enter our skies, and we have the means to see them. To live in such a time is to live in a rare age of awakening. Wonder balances fear. Fear reminds us how small we are. Wonder reminds us that smallness can contain meaning. Fear shows the abyss. Wonder shows the beauty of gazing into it. In the story of three, I divided by Atlas. These emotions intertwined like shadow and light, fading together as the fragment slipped deeper into darkness. Scientists knew they would likely never solve its riddle, but perhaps that was not failure. Perhaps the true gift of Atlas lay not in explanation, but in experience, the reminder that encountering the unknown is itself a privilege, a fleeting intimacy with the cosmos. Almost as quietly as it had arrived, Atlas began to fade. Its path carried it away from the sun, past Earth, and back into the cold depths from which it had emerged. Telescopes strained to follow its diminishing glow, yet each night it drifted further into obscurity. Soon it would vanish entirely, indistinguishable from the sea of stars, leaving only records, measurements, and the memory of those who had watched. There would be no grand revelation, no sudden burst of insight, no comet-like tale ignited to explain its nature. It departed with quiet dignity, indifferent to the questions it left behind. In this, three I divided by Atlas resembled Oumuamua. Both had slipped through the solar system like ghosts, silent, unbound, vanishing before certainty could catch them. Their departure carried a peculiar ache. For scientists, there is comfort in repetition, the ability to observe and re-observe until doubt yields to clarity. But an interstellar visitor allows no such luxury. It passes once, its secrets must be seized in the narrow window of its appearance, and whatever is missed is lost forever. Atlas departed with its mysteries intact, sailing outward into the abyss, beyond the reach of human instruments. Yet there was profundity in its vanishing. Its silence was not emptiness, but resonance. Every unanswered question, every fragment of data, became a seed for future inquiry. The absence of closure carried its own message. The universe exists on its own terms, not to satisfy curiosity, but to unfold in its vast rhythm. Even in an age of satellites and space telescopes, the cosmos retains the power to withhold. Science, for all its progress, remains a dialogue with a partner who often refuses to reply. Sometimes the most important truths lie not in revelation, but in what remains unresolved. As Atlas disappeared into the dark, the astronomers who had studied it knew they would likely never see it again. It would drift for millions of years, perhaps brushing past distant stars, perhaps wandering endlessly through interstellar space. Its story with humanity was brief, yet its silence lingers. In that silence lies a reminder: the cosmos is vast, patient, inexhaustible, and every mystery is also an invitation to keep looking upward, to keep wondering, to remain awake in the face of the infinite. When at last the object vanished from view, the night sky felt subtly transformed. Not because the stars themselves had shifted, but because something had passed through that made humanity pause and reckon with its place in the cosmos. 3i divided by Atlas was no larger than a modest mountain, no brighter than a faint flicker of starlight. Yet its passage carried the power to unsettle entire frameworks of thought. Its shadow was not cast across space, but across the human imagination. In lecture halls and laboratories, scientists continued to speak of it cautiously. Models were debated, trajectories recalculated, papers revised again and again, as if one more equation might unravel its secret. But in the quiet spaces beyond numbers and charts, reflection deepened. What does it mean that a fragment from the void can glide through our solar system and leave behind nothing but questions? What does it mean to exist so small in a universe so overwhelmingly vast and strange? Philosophers stepped in where astronomers left off, reminding humanity that the cosmos is not only a subject of observation, but also a mirror of existence. If objects like Atlas can traverse interstellar gulfs, so too must humility traverse the boundaries of human ambition. The mystery it carried was as much existential as scientific. It reminded us that the universe does not revolve around us, that meaning is never guaranteed, and that understanding is always provisional. Yet, within this humility, lay an unexpected gift. 3. I Divided by Atlas revealed the fragility of our comprehension, and at the same time, the resilience of our wonder. Fear and awe were entwined in its passage, but both pointed toward the same truth. We are alive and aware in a universe that will always surprise us. To witness an interstellar visitor, even one that speaks only in silence, is to remember that we live not in isolation, but in connection. The stars are not distant abstractions, but neighbors whose stories occasionally brush against our own. The shadow left by Atlas is therefore not one of despair, but of depth. It teaches that science is not the conquest of all mysteries, but the practice of living with them, of moving along their edges, letting them expand our sense of being. Though the object is gone, its questions remain vibrant and alive. They are the true legacy of its journey. Perhaps this is the purpose of such visitors, not to deliver answers, but to provoke questions. They remind humanity that the cosmos is vast beyond comprehension, and that within that immensity we are both minuscule and extraordinary, creatures capable of noticing, imagining, wondering, and dreaming. As the fragment recedes, fading into the endless darkness, its silence softens. It merges with the countless invisible wanderers drifting between stars. No longer is its quiet unsettling. It becomes gentle like a door closing softly at the end of a long night. Fear gives way to calm. The universe has always been greater than we can grasp, always populated with riddles beyond our reach. To dwell obsessively on them can exhaust the spirit, but to acknowledge them, to let them exist, is to find peace in mystery. 3 Divided by Atlas has passed, yet the stars continue to shine, Earth continues to turn, and life continues in its fragile, beautiful rhythm. Perhaps the ultimate lesson is this: we are not meant to dominate the cosmos, but to participate in its wonder. Each anomaly, each silence, is part of a conversation that stretches across time, in which our role is not only to measure, but also to marvel. Let the memory of Atlas drift into the cosmic expanse, leaving behind the quiet gift of perspective. Let its mystery remind us that the unknown is not an enemy, but a companion, always present, guiding us toward deeper humility. As night settles and the sky deepens, let that humility become comfort. For the universe does not need to reveal all of its secrets at once. Sometimes it is enough simply to remind us that we are part of a story still unfolding,